Hi again, everybody. It's Mr. Rooney talking here, and we're going to do some problems related to Section 8.1. They're all one-step equations, which we've been doing for actually a few years, but they've got some wrinkles in them, as you know. So I'm going to give you examples of some of the more challenging ones. So, and these are all out of Section 8.1 in your textbook. So this first one is we'll go maybe full screen here. This first one is dealing with when we have a fractional coefficient, and a fractional coefficient means um, rather than having a coefficient that says like I don't know 3x, we've got a coefficient that's actually a fraction. So that can be a little more challenging. And one thing I'm going to get you to try to utilize, like a lot of times we'd want to say, well, okay, we'll divide 2/3 by 2/3, and we'll go over here on this side and divide by 2/3. Well, all that's fine and well. We still have to make sure we remember to change this to multiplication, make the reciprocal here, and so on. So those are a couple of extra steps involved. So I'm going to get you to try a different technique on that. And rather than dividing, I'm going to get you to try to multiply by what's called the reciprocal. So the reciprocal of 2 over 3 would be 3 over 2. So we're going to try that, and then we're also going to multiply that by 3 over 2 on this side. Okay, so what that does is right away we don't have to worry about any sort of reciprocal over here because it's already good. And we flip that over and we made it into multiplication, so we're all set. And the beauty of multiplying by a reciprocal is that it cancels fully. So that's gone and that's gone, and there's what we want. We want x, right, by itself. So we're going to convert this into negative 7 over 6. And we're going to multiply then by 3 over 2. So there's no changes required if you multiply by that reciprocal. So we could do a little canceling here. We cancel 3 and 6, and in its place we could drop in a 1 and a 2. And then the last step is just to finish that off. We've got a negative, so we've got negative and then 7 by 1, and then 2 by 2. So I'd probably look at that and make it negative 1 and 3 over 4, just to dress it up a little bit. And the best part of those who show their work well in equations should be able to pretty well draw a straight line or almost a straight line down there and sort of see left side and kind of right side. Whoops, I'm into a there. That's quite a zigzag, isn't it? Okay, so we're going to look at another kind of something that's a little bit unique here. And what's unique about this is here's our variable, and we've got it as a denominator. So we've got the variable on the bottom this time. So what I'm going to get you to think about is what's called cross multiplication. There's a couple different ways to do this, but cross multiplying will do this. Normally when we have, if this were reversed, for example, if this were j over 1.4 equals 2.3, let me ask yourself what you would do there. Well, you'd probably say, oh, well, I'd multiply by that denominator 1.4, multiply by that denominator 1.4, and that cancels, and the answer is whatever that is. So we're going to do the same thing. We're going to execute that. We're going to multiply by that denominator. This time the denominator happens to be j. So we're going to multiply this by j and this by j. Okay, we're going to get that desired effect of canceling that. So we got 1.4 here, and we end up with 2.3 by j. You may not remember that from the algebra stuff, but 2.3 by j is just 2.3. And then we just have our one step left to do here, divide both sides by 2.3. So that's a little funky, but that's probably the easiest way to go ahead and solve that. And what do we have for an answer there? Where's my calculator? I don't know. Doesn't matter too much what the actual answer is, but yeah, 0.6 or something. So that's good. Okay, so that's how we do with a denominator, with a variable as a denominator. So a couple of written problem things that we're going to try here. All right, let's go ahead and get to the next page. So we're going to use and we do this a lot in science as well as math, is we use formulas. Formulas can be used over and over in the same format, and we just have to plug in a couple of different values, right? So here you've got, this is an example from your book, so you'll probably find, I think it's a show, this is problem 3. So a musher and a dog team averaged 23.5 kilometers per hour. Well, 23.5 kilometers per hour, that's speed. So that's going to go where the S is. So we're going to replace the S with 23.5. And then we're going to keep reading. How long will it take to sled 50 kilometers? Well, it sure sounds like distance to me. So I'm going to replace the D with 50. And what we have left then to find is that T. Now we just finished doing a problem where the variable was on the bottom. And you have to show the substitution. Again, remember trying to keep the left side and the right side always, clear and easy to follow. So let's try that technique that we saw in the last example. Here's our variable. Let's multiply by that denominator. Cancel that out. Gone. Multiply this side by t, and we get 23.5 t. And then on the other side we have our 50. And so our last step is just going to be to divide as you would normally by 23.5 on both sides. So in this one we want to make sure we get our units right. I'm using a mouse here tonight, so it's a little bit messy. So whatever our answer is there, it's 2 and change, 2 something, 2 decimal, whatever. So we want to make sure we get the correct units there. So the 50 was kilometers. The 23.5 was kilometers per hour. Well, those actually cancel, and look what units left over. So when we see that canceling, the kilometers and the kilometers, well, what's left is hours. I mean, if we think about what it is, we're talking about time, so it's 2 point whatever hours, and we're going to round it to the nearest tenth of an hour. Well, maybe we better have a look at that with the calculator, just to make sure. Calculator. So we've got 23.5, sorry, we've got 50 divided by 23.5. Yeah, 2.127. So 2.127, we're going to round to the nearest tenth, is 2 decimal 1. And because that's a 2, we're going to keep that as 2.1. Okay.